Hello, in this video we're going to look at writing the energy term within a reaction equation. First, let's go over the units that we'll be using for energy. So enthalpy has the units joules, or more commonly kilojoules. Let's consider the reaction A transforming to B with a delta H of negative 50 kilojoules. That negative sign tells us that the reaction is exothermic, which means energy is exiting the system. Now, if energy is exiting the system, it is being released. Therefore, energy is a product. So we can write our reaction equation as A forms B plus 50 kilojoules. Let's look at another reaction. C forms D with a delta H of 120 kilojoules. Now here we have a positive delta H, so the reaction is endothermic and the energy is entering the system. If energy enters the system, it is a reactant. So our equation will write C plus 120 kilojoules forms D. Let's look at the energy term in a real chemical reaction equation. Let's take the reaction of carbon dioxide plus water to form glucose and oxygen. This reaction occurs with a delta H of 393 kilojoules. So this is a positive delta H, which means it is an endothermic reaction, and the energy enters the system. So we can now rewrite this equation as carbon dioxide plus water plus 393 kilojoules forms glucose and oxygen. This reaction is known as photosynthesis. And plants take this energy from the sun in the forms of heat and light and stores the energy within the chemical bonds of glucose. Then let's say an animal consumes this piece of glucose. Its cells can use the energy stored within the glucose bonds to fuel its own metabolism. This is how energy is passed down the food chain. It's all about chemistry. Now let's take a look at a combustion reaction with octane and oxygen forming carbon dioxide and water with a delta H of negative 10,992 kilojoules. This negative delta H tells us that the reaction is exothermic. Energy is exiting the system, and so it will be a product. Now we can rewrite this 10,000 kilojoules in the products. So our reaction will become 2 octanes plus 25 oxygens form 16 CO2 plus 18 waters plus 10,992 kilojoules. Now, octane is a component of gasoline, and when this combustion occurs, all of this energy is released into the surroundings. And this energy can, for example, be used to turn the wheels of a car. Thanks for watching.